Welcome to our lesson today. Our lesson today, we are going to look at waves 1. In our previous lesson, our previous topic, we looked at Hooke's law, and we were able to look at Hooke's law, the practical and the numerical problems. So today, we are going to look at the topic of waves. And in this topic of waves, there are a number of objectives. By the end of this topic, you as a student, you need to be able to describe the formation of pulse and waves. You would also be required to describe the transverse and longitudinal waves. You are supposed to differentiate between transverse and longitudinal waves. You will be able to define amplitude, wavelength, frequency, and periodic time, and any other terms that are associated with waves. We'll also be able to derive the wave equation, which is V is equal to F lambda, and then we'll be able to solve numerical problems that involves the wave equation, V is equal to F lambda. This is one of the most interesting topics in physics, and I know we are going to enjoy. So, for the introduction part of the waves, we know that waves is a branch of physics. And in this topic, basic concepts about waves, we'll be able to study them. The knowledge about waves has been broadly applied in our daily life. For example, waves are very, very important in our day-to-day life. You require waves for you to be able to tune into your favorite radio station at home. You require the waves for you to be able to watch that television. You require waves for you to be able to communicate using that mobile phone. You require waves for you to use that remote control system as you change the channels in your TV. You also require the waves for you to warm yourself, maybe even under the sun. When it is cold, you go outside there to bask under the sun, or you move near the fireplace for you to warm yourself. You require wave. Those are the heat waves. So wave is applied in our day-to-day life. Even the light we are using here is a product of waves. So waves is there in our day-to-day life. You are able to hear me because of the sound wave. So the sound I'm producing, you are able to hear because of the sound wave. So wave is very important. Without waves, it becomes very difficult for us to exist. Communication and technology, all that requires waves. So the advancement in technology in our modern life, in the modern world, greatly relies on waves. So the application of waves will give us, it gives us a lot of benefits. So let's look at the definition of a wave. So a wave refers to the transmission of a disturbance. And when a wave happens, it is not about the medium being moving from one point to another. You are able to hear the sound from me, not because I'm moving from here to where you are, but it is the energy, it is the disturbance which is being transmitted from one point to another. For example, one practical example is those times we normally have the earthquakes. The earthquake may not be emanating from here in Kenya. It may be coming from the epicenter, maybe in Tanzania, maybe in Lake Kivu. So what happens is that wave is transmitted from there to Kenya. It is a disturbance that is being transmitted. We are able to feel that wave because a disturbance has been transmitted from all that side to this place. So it's only the energy which is transmitted, but the medium does not move. We have different waves can be broadly classified as either electromagnetic or mechanical in nature. And today we'll be looking at electromagnetic waves. Electromagnetic waves, these are waves that do not require material medium for transmission. It means that if these waves do not require material medium for transmission, then it means they can be propagated in a vacuum. These are waves that can be able to move in a vacuum. Examples of electromagnetic waves. We have radio waves. We have the radiant heat, e.g. the heat from the sun, light, and microwaves. These ones, they don't require material medium for transmission. So they can be able to move even in a vacuum. And they are very, very important because sometimes, like for example, heat from the sun, it passes through the vacuum to reach us. So that's how we can be able to receive heat from the sun, because it's an electromagnetic wave. So electromagnetic waves are transverse in nature. We'll be looking at other classification of waves, whereby we'll be talking about transverse and